Okay, so good evening everyone, and bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects, titled Spiraling into Control, a different way to plan and teach math for deeper student understanding, with Marie-K Goindy. We have a very large group tonight, with some experienced users and some new users, but Marie-K is very experienced. She's one of our leading facilitators, and I'm sure it's going to go smoothly once she takes over. As usual, I would like to thank you all for taking time away from your families to join us over OTF Connects. Et comme d'habitude, je voudrais aussi profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Nos sessions sont principalement en anglais, mais si vous désirez obtenir des informations en français, n'hésitez surtout pas à me contacter par la suite. We are definitely thrilled to have each and every one of you with us tonight. It's also our absolute pleasure to welcome Marie-K Goindy. Marie-K has over 20 years of hands-on experience teaching in kindergarten, intermediate level, as well as all the way to teaching some math courses at York University. She also spent 4 years as the curriculum leader with the math portfolio of her school board. She currently is working as a teacher's librarian and has facilitated many OTF Connects webinar and OTF Summer Institutes over the recent years. So she's one of our most experienced facilitators, and that reassures me that everything is going to go very smoothly tonight. So at this point, Marie-K, I'll invite you to click on your talk button and take over, and wish you good luck. Everything is going to go smoothly. Thanks.
Merci, Michel, and welcome everybody. I saw that it was the first webinar for a bunch of you, so I do just want to reiterate, in the chat box, chat about what you want. My goal for you tonight is at the end of the night you walk away feeling that you learned something, and if it's not from me, I'm okay with that. If you learned something from another participant through a conversation in the chat bar, I am thrilled with that. And speaking of the chat bar, so that you can connect, because some of the best connections happen when you co-attend a PD session together, if you've got a Twitter handle, if you want to type it in the chat right now, because you may hear a comment or see a post from somebody else tonight and you think, oh, I want to get in touch with that person, Twitter might be the best way. So if you want to fill up that chat room right now with your Twitter handles, if you got it, email if you want. I mean, any way you want others to contact you, feel free to put that in the chat box right about now. And I put my email in just before the recording started, so if any of you want to contact me via that email, you're welcome to do so. While that's happening, maybe we can use that polling tool just so I get a sense of who's in the room. And I know when the polling tool it says yes and no, but we'll ignore the yes and no and just go by green check mark, red X. So if you are in the secondary panel right now, could you give me a green check mark? Or if you're working in the elementary panel, a red X. So green for secondary, red for elementary. The tally, I don't think you can see it, but right now we're 34 elementary and no secondary. So just getting the room of that. I'm going to clear that poll for myself. Oh, one secondary. Yay, one. Welcome. I can't see who that was. Oh, maybe they were just teasing me because it's gone now. I'm going to clear that poll for myself. And another poll. Could you give me a green check mark if you're currently teaching math? And a red X if you are not teaching math. Just give you a second to finish that up. There's green for math. At some point in the day you teach math, and red for no math. Oh yeah, Lisa keeps rubbing it in on that self-funded leave. I'm so envious. I needed to plan that out. So that poll says 33 are teaching math, mostly daily, and 5 are not. That's excellent. My last question is, have you ever tried spiraling the curriculum before? Green check mark for yes, you've tried it. Red X for I have not tried spiraling yet. Awesome. We have 13 who've tried it, to some degree and 24 who have not. I'm going to clear that poll, and right now we're at 14 who have. Could you give me, for those of you who have tried, could you give me a green check for was it a success and a red X for you're not going to weigh in on that yet, you haven't decided. So, and for that poll it looks more successful than not, and just haven't weighed in on it yet, so the red X doesn't necessarily mean it wasn't a go. So for those of you that haven't attended any of my webinars before, I just want to give you a little bit of my background in terms of what I believe in for effective teaching of math. I believe strongly in teaching math through problem solving. So every time I'm introducing a new concept to my students, I don't pre-teach it. I give what I hope is a rich problem or maybe a design challenge, and I let them muddle through, bringing all the schema that they bring to their class already and see what they can do. I usually teach that way through the 3-part lessons, where I'll start with a minds-on, and then in partners I'll have an action time where students get about 15 minutes with their partner to wrestle with the solution, and then I wrap up that lesson with about a 30-minute consolidation, which would be the first part is students sharing their work with other students. Then we compare, which is I will kind of do a teacher-guided walk through the concepts that I see. And then the last 10 minutes is my time, where I really hit my learning goals with the students, and I'll make sure that I've brought out the important instructional pieces that I want to focus on. And then I guess the fourth part, there'll be some independent practice, where students will do a couple tasks on their own. And that's how my math class usually runs. I believe very strongly in the productive struggle. So I believe that students have to have that cognitive dissonance for there to be learning. And actually I believe in cognitive dissonance for all learners. So I'm hoping tonight that some of the things I say will make you nod your head and feel good. Oh yeah, I do that. Okay, yeah, that's familiar with me. And I hope for all of you I say something that jars you out of a comfort zone and makes you go, what? What is she talking about? That's wrong, because even if you ultimately still disagree with me, it will help you strengthen your belief in that. And maybe when you hear something that kind of jars you, your learning might shift a little bit too. My math class is loud. It's usually got motion and manipulatives and all kinds of communication, not just communication initiated by me, or it's not from the teacher to the student. There's lots of student-to-student conversations, and I believe strongly in different ways of knowing, so students don't have to show me their understanding the same way as their neighbors. I try and open it up for students to show me their learning any way that is comfortable for them, and they just know things differently, and I try my best to honor all of their different ways of knowing and their different ways of showing me what they know. And I see Julie asked a question in the chat about do I have many who get frustrated? And yes, and even more this year with me trying to do the spiraling. But I hate when people tell me this, but if you can hold on to that question, I hope I answer it throughout the presentation. I'm going to clear that and go on. Does anybody have, you hear me well, you've got thumbs up if we're good to go, kind of, and okay, I'm going to go on then. Awesome. So I hear lots of clicks. Was that hands up because you want to talk, or was that a hands up because, like, raise the roof, woo-hoo, kind of thing? So I heard the dings, but I can't see them. So maybe, Michelle, if you think they want to talk.
No, I think it was just a thumbs up that okay. when they click on it, yeah, don't worry about it.
Because I can't follow the chat. Sorry. Oh, it's good to stretch, Greg. Thanks. So given all that I've just told you, I've still had lots of frustrations teaching my math. The silos that are created by the strands of the math curriculum were driving me nuts. And as I read, I realized that there is no reason in our curriculum to teach in silos. We don't have to teach by the different strands in the math. In fact, our curriculum tells us it's our responsibility as teachers to not teach by the strands, to teach in an integrated fashion, to teach cross-strand and even go beyond the math curriculum and teach cross-curricularly. But then why do we all feel that pressure to do a number sense unit and then do a measurement unit and the geometry unit and go through it that way? And my gut is that it's just tradition. And education is so stuck and kind of, I'm going to use the word paralyzed by tradition. And if you've ever walked into a new staff and sat in the wrong chair in the staff room, you understand this sense of the tradition of certain schools. And I think, you know, that was part of the problem. Yeah, reporting purposes too, but I have a feeling that that's going to be changing. So whatever. I am going to turn my page. Something else, I believe in teaching through problem solving. I told you that. But as I was teaching a unit, the longer I was in the unit, the less productive struggle there was. Because if I tell my students that we are working on a measurement unit in which we are going to explore area of circles and volume of cylinders, it doesn't take very many days in a row for students to really have to stop thinking about what they're going to be doing in class and just blindly executing an algorithm. And that is not the productive struggle that builds real permanent learning. It might create a lot of right answers. It will probably create a lot of students that feel really good about themselves because they're getting the right answer, because they're not very good at judging whether or not they're learning. They equate right answers with learning. And again, I'm going to get back to this point. I will argue that a right answer doesn't necessarily mean that there was any real learning at all. So my way around this was I used to consolidate all the content expectations early in the unit. So when they're just figuring out what this thing called pi is, and that it's that relationship between the diameter of a circle and its circumference, and it's 3 and a little bit. And we're just learning how we can use that to find circumference and how to find area, and then that in turn gets used for surface area and volume. So early in the unit, that's what my learning goals would be, and in that end of my lesson, those would be the points I was driving home. Those would be the anchor charts I was building to put on the wall. And then as that became comfortable for the students, I would switch my learning goals more to the process expectations, and I would really focus on how are they communicating their solutions, how are they using those formulas, how are they recording them on paper, how are they talking about it, and focus on the process. But you know, it's kind of hard to assess and provide feedback on process when, like, for example, one of them is choosing effective computational strategies. Well, if we're finding area of circles, there's really only one computational strategy to use. And so for me to provide feedback on that was kind of artificial, and students weren't really making a choice because they figured out what it was. Do you remember, I was going to say, like back in grade school when I was there, the top of the page we would practice multiplying, and then at the bottom there'd be word problems, and you didn't even need to read the word problem. You just grabbed the answers and multiplied, and then maybe you had to read the end of the questions because that was the beginning of your statement at the end to get the full mark for solving the word problem. I was thinking that my students were having the same experience, and that's not a lot of deep learning. Then this, that we're all in the middle of right now. It's report card season, so this is our friendly document that we go to often. I'll let you read that quote. It's right out of Growing Success. And I did add the emphasis at the end with the italics. how do I give special consideration to the most recent evidence if I finished the unit in October and they yesterday showed me that they now understand how to work with variables? Do I just change that mark? I haven't really formally assessed them, but I've seen them, I observed them in my class, and now they can do it. So the whole unit approach and the final test and all that didn't really jive with my understanding and how I wanted to work with growing success. So all of these things were really starting to make me think, like, something's not right. I have to do something differently, because I was kind of driving myself a little bit nuts and spinning in circles. And then somebody passed me this book, and I got to say, after 26 years of teaching, it was a little bit hard to read this book, because I realized, or I felt when I was reading it, that a lot of what I have done in the past was wrong. And it's like, oops, sorry kids, it would have been good if I'd learned this in my second year, but you know, I think it's Oprah who says we do the best we can with what we know. And so that's the summary of my career, but now I know better. If you have, well, thumbs up, green check if you've read this book, red X if you haven't. Okay, and that's most of them no's. I've got over 30 no's already. Okay, if you haven't, I would suggest it's a good read. It's not all anecdotal, but there's a lot of anecdotes in it. It's not like reading a really dry, you know, summary of research, but it is all based on cognitive psychology and what we are learning about how brains work and how learning happens. So I would suggest it. It's a fascinating read, and it has changed my classroom, which is always good. Hopefully it's an improvement, not just a change. So, some of the ideas presented in the book. Maybe this pattern is very familiar to you as a classroom teacher. We study a unit, we test it. We study another unit, we test it. Study the third unit, we test it. And that's kind of how we go along about our school year. It's nice, it's comfortable. Parents expect school to go this way. Students expect school to go this way. Our data collecting support tools expect school to go this way. And, you know, it's kind of just how we think teaching should happen. If we really want a student to learn a skill, we practice it over and over and over and over again in a short period of time, hoping that that just kind of hitting it again and again and again will make it second nature to the student, and they can repeat it without prompting, and we translate that to be they've learned it. I want to read to you from the very front flap of the book. It says, many common study habits and practice routines turn out to be counterproductive. Underlining and highlighting, rereading, cramming, and single-minded repetition of new skills create the illusion of mastery, but gains fade quickly. So this approach, they suggest, will have short-term gain and no lasting effect, creating an illusion. So, right now, I've got something on the screen. If you could stare at some part outside the circle for the count of 5. 1, 2, 3, 4, 5, and then look within the circle. Green check if you sense motion or see quivering. Red X if you don't. Yeah, so far everybody, that's 36, 37. Oh, there's 1 X. So somebody sees it now. There is no movement in this. This is a stationary image. It's not a GIF. Nothing is moving. But you have the illusion that this is moving. That's an illusion. You think you see something that actually isn't there. That traditional approach to teaching, the book suggests that creates what's called an illusion of knowing or an illusion of mastery. They call it both in the book. That whole notion that we test them right after the unit makes us feel like they have learned it. But really, that is still just fresh in their working memory, and they can just put it down on paper. But when it's in the working memory, it's not really a learning yet. Maybe you've had the experience as a student. Did you ever walk in to a test or an exam feeling well prepared, but then you walked out wondering what the heck happened? Is that a familiar situation to you? You remember that? Or maybe you've been the teacher and you have, felt you did a really great job helping students understand fractions, or maybe, data management. So I've done my data management unit, and my grade 8s seem fabulous at creating scatter plots. And they all walk out with very positive achievement results and evaluations, and I'm happy. And then in my geography unit, maybe 2 weeks later, we're doing scatter plots where we're comparing socioeconomic data, and the students can't even get started on their own. And I wonder what has happened. I fell for the illusion of knowing. I believed students had learned something because of their performance on a test in that very traditional structure. Here's a quote from the book. It was a little bit awkward to read at first. So both the learners and the instructors fall victim to that illusion of knowing or illusion of mastery, because the performance is fleeting. And so it was there when we were assessing, but it's not there down the road. And we don't, as teachers, often realize how poorly our assessments actually do capture learning. And I think that's a problem. The other thing the book talks about is making connections. Students are smack dab in the middle of two concepts that are very closely related, but because of the ways instruction happened, students miss that connection together. I hear this all the time. I feel the frustration from my students because they say, I didn't know that was related. I'll talk to the science teacher, and they'll be struggling to apply a math concept in the science class. And so all of this is a disconnect between our intuition and our traditional practices, and what we are now learning through cognitive psychology is actually effective strategies to support learning. Yeah, Lisa, I see that. Integration has to happen, absolutely. But with planning time and everything like that comes in, then we got 3 teachers teaching an integrated program, and it kind of falls down, unfortunately, but it's true. So, going back, the book then goes and talks about 3 practices that we could bring into our classrooms as teachers and learners, and that would help counteract tradition and intuition. The first one is they call spaced practice. Green check if this is a term familiar to you. Red X if you have not heard of this in an educational context. Okay, so Michelle showed you where that writing tool is. I invite you, take a risk if you want. We'll see it if it's your guess if you type it in the chat, and it will be completely anonymous if you type it on the screen. What do you think this might mean in educational context? This whole phrase of spaced practice. Grab a tool and start typing what you think it might be. Chat or on the screen. Just going to take a minute, and I'm going to take a sip of tea. Yeah, I like the not just once and done and move on. That is kind of the tradition, but space practice is not that. Coming back to concepts repeatedly, revisiting and practicing with time-lapsed. Absolutely. You know, these words kind of make sense to support that. I'm just going to wait for a second because I see a few more people typing on the slide, and I do like these ideas to get captured in the archive. Awesome. I don't see anybody still typing, so if I cut you off, I'm sorry about that. In the book, they talk about space practice in the concept of med students. They talk about a study where they tracked 38 surgical residents who were working on microsurgery. So I believe they were reattaching an aortic valve in a rat. I believe that was the microsurgery and had to reconnect nerves. And so they had 38 surgical residents, and they split them into 2 groups. Well, they all received 4 mini lessons on microsurgery. Half of these students got all 4 mini lessons in one day, and that was normally how these mini lessons were delivered to these students. The second half of the group got 1 of these mini lessons per day, 1 week apart. So while one group's mini lessons happened in one day, the others happened over the span of a month. Regardless, both groups were tested 1 month after their last lesson. The second group outperformed the first group by about a 40% improvement in all categories, which were elapsed time, the number of hand movements, and the successful reattachment of the aortic valve. So both cognitive and physical performance was improved by the group that had their lessons spaced out. Spaced practice. Okay, we'll come back to that idea. And this idea was actually talked about by Robert Bjork, and he is studying, well, first of all, in this clip, and we're not going to watch it now, but I wanted you to have this link, so if you're interested, it will be in the archive, or you could bookmark it now, or if you wanted, you could watch it now. I wouldn't know. But he says in this, first of all, that space practice has begun since, get this, 1885 was the first educator who tested the theory of spaced practice. But he talks about how space practice improves long-term retention. That's what clinical psychologists are realizing, that just by spacing out instruction helps learning. Hell, you cannot space out without mixing the silos. Isn't that an awesome byproduct of spaced practice? You have to cross strands. I agree. And I should say the opposite of space practice is called massed practice. And so you'll see that term, and it'll be in the video if you choose to watch it, and we may talk about it a bit later. Did anybody, oh yeah, cramming absolutely is mass practice. And actually, Bjork will tell you, if you have an exam, cramming is a good thing to do. Cramming will improve your performance on the test, but it will do nothing to help you learn the content. So there is a difference there. Thanks for reminding me about that whole cramming. So the second practice that we have to consider, or I hope you consider, I've definitely tried this, is called interleaved practice. So again, green check if you know what this means, and red X if this is the first time you've heard this term for education. Interleaved practice. Yeah, I hadn't heard it before I read the book either. So 34 of you, 35 of you that, oh, more who said you don't know this, interleaved practice. Well, do you know what an interleaf is? Green check if you know what interleaf or an interleaf is. Maybe you've read books, because that's where it's actually from. Have you ever read a book with illustrations, and before the page of illustrations they have that little waxy or almost tissue-like piece of paper? That is an interleaf. So it's between two things in a book. Yeah, exactly. Inter is between, and the leaf is just like that divider. And so interleafing our practice. That's what interleaf is outside of education. Well, here's the study that they talk about to support this, and I think you'll very quickly see that really this is probably what we think about when we've been talking about spiraling. And the study they quote involved, I don't think they told how many people were in, but they were working on having students calculate the volume of these four 3D figures, the half cone and the spheroid and the wedge and the spherical cone. This is not elementary math. This is beyond elementary math, but it was the study that they used to support interleaving practice. So they split, again, the groups into two. So all the students were split into two groups. One group got clustered practice. So one group learned and practiced how to find the volume of the half cone. And they did it, and they did it, and they did it, and they did all their calculations about the half cone. And then when they thought they were done that, they went on to the spheroid. And they worked on the spheroid over and over and over again, et cetera, until they'd covered all four of those 3D figures. And then the other group received interleaved practice. So they learned a little bit about the half cone, and then a little bit about the spheroid cone, and then the spheroid, and then the wedge, and then back and forth and back and forth. They learned the concepts in a mixed up order and all kind of integrated, and they had their practice in mixed up order and again, integrated all four solids. So here were the results. When they tested right after the practice, the clustered practice scored 89% correct, and the interleafed practice got 60% correct. So again, that's 89 for clustered and 60 for mixed practice or interleafed practice. So that seems to not support bringing in interleaved practice into your classroom. But 1 week later, students were tested on the same skills. The clustered practice group scored 20% correct, and the interleaved practice group scored 63% correct. So whereas the clustered group fell 69% in the week, the interleaved practice group actually improved by 3% over the week. Interesting. Think about how we teach. Okay, we teach by strands. We practice one thing, then we test them, then we move on. I don't know about you, maybe I'm making a false assumption. My practice relied heavily on clustered practice for students. And it's that illusion of knowing. Oh yeah, 89% correct. I rocked that unit. I must have hit all the instructional points at the right time, just the right way. My students were successful. And if I didn't retest in a week, I would live on with that false assumption. So, interleaving, definitely something to think about. The third is varied practice. That's just what it is, varied practice. We should change things up. Here's the example that they talk about here. They needed a group of students to be able to throw a beanbag from a distance of 3 meters through the hole. So they got a group of students, and again, they divided them into two groups, and one group stood 3 meters away from the hole, and they kept practicing and practicing and practicing from 3 meters. Another group only stood either 2 meters away or 4 meters away. They never practiced the 3-meter throw. Which group did better? I mean, you know, because I wouldn't be talking about it if it was, right? The group that only practiced from 2 and 4 meters outperformed the group that practiced 3 meters on a 3-meter tossing challenge. That kind of shocked me. So those were the 3 different types of practice that the book suggests we bring into the classroom. They talk about some other things that were really interesting to me, and so I do want to hit on them. They're pitfalls, and they warn us, don't fall into the pitfall of tradition. We have to be able to break away from tradition and react to the new information we are getting. You know, before, to learn about the brain had to be cut open, which wasn't very good for our student population, so we just kind of assumed we knew what was going on. But now, brain technology, brain science, we can see what's going on in the brain through sensors while living students get asked a question. We can see what part of the brain lights up. So don't fall into the trap or the pitfall of tradition. Also, Skinner, back in the day, used to talk about error-free learning. And the notion in education was if students were making mistakes, they are going to learn the mistake and not learn the right way. And yes, there were air quotes when I said right way. Because there was the belief that student struggling was bad. And if we were good teachers, we would scaffold or we would present the information in such a way that students didn't need to struggle, that they were just obvious solutions to be followed and, you know, the right answer, and everything was roses and rainbows and all things like that. But the book says when student makes errors, it actually frees the brain up to learn more, so long as this happens. So back to growing success. It was like the person who wrote Growing Success actually read a lot of research. I know people like to speak badly of it, but it is really well-founded in cognitive science and cognitive psychology. So in the book they say error-filled learning, so students are allowed to make mistakes, is highly effective support for learning if effective corrective feedback is required. And that is definitely what Growing Success calls on us to provide to students, effective and corrective feedback. So a couple things I want to point out. It says give and receive specific feedback. Teachers think that the responsibility is to just give the feedback. They have to actually receive feedback from students, which means sometimes we need to ask for it. So that's a little point that we have to do. Book talks about desirable difficulties. If we want students to have error-free learning, it can't be easy for them. If it's easy, it's called practice. If we want them to learn new things, there has to be that cognitive dissonance. And the cognitive dissonance is caused by what the book talks about as being desirable difficulties. And I think it was that man Bjork who actually talked about this phrase and coined it. And it's in the grappling with the impediments to easy learning, that's what makes learning challenging, and that's what leads to complex mastery and to better retention of what was learned. I don't know if you follow, he's an Ontario high school educator. His name is John Orr, and he's been tweeting recently, I saw one as recent as last night, about productive struggle. It's that is key to help our students learn math. It's not showing them numerous examples of how to do it. It's putting them in situations of productive struggle or desirable difficulties. So one of the most points of desirable difficulty is called by retrieval practice. The whole thing about learning, it's not learned unless you can recall the fact or the skill and use it again. And learning is stored in your long-term memory. His name was John Orr, J-O-N-O-R-R. Sorry, distracted by the chat. And so students have to have time to put the learning and shift it from their working memory to their long-term memory, and then they have to have the skills to be able to pull from their long-term memory when they need it. And they will suggest that it's through spaced practice and interleaved practice that we give students the time and the opportunities to practice retrieving what they know. And the thing about the brain, the more often students have to go back and retrieve ideas from their long-term memory, the easier it gets for them. It's like a highway with new road paved, and then a wider lane gets put in, and then you get your HOV vehicles going down. So the more we have students go back into their long-term memory and pull the appropriate fact out or the appropriate skill out, the easier it becomes for them. Second desirable difficulty is they talk about the need to discriminate. Students need to be able to read a task and recognize and choose what is required. They have to be able to see what is the same and what is different. So, for example, if I am having students either calculate the hypotenuse of the triangle or calculate the area of the triangle, they know it's in their brain and it's something about triangles, but they have to know what's the same and what's different about those two formula, and then they have to know what the situation calls for, and they have to bring that back and use that idea and that skill at the right time. It doesn't happen so much in the traditional teaching because there is no need to choose the effective strategy because it's the one that we're doing the unit on. So that's kind of important. And the book talks about how it's the interleaved practice and the varied practice that brings that up. This is my favorite notion. When we teach, we need to interrupt forgetting. And that is how we build student learning. Real student learning happens when teachers keep interrupting their forgetting. I just love that idea. Seems so simple. And that's the time to review. If we review the next day before any forgetting has happened, it is a far less effective strategy to support their learning than if we review a week later. Once they've started to forget some of those ideas, that's the optimum time because that helps them practice their retrieval. So here's, and I think probably Michelle's going to put a link to a clip that I stole this from or screen captured this from. There it is. But overcoming the curve. So if you can read this graph, the bottom, the royal blue line says that if we don't review at all, 1 month after we've taught something, most students will remember 10%. If we review it immediately after class, most students will remember, just over 10, maybe 15% of what we've taught. If we review it a day later, the yellow line, do you see how 1 month later, they're still remembering about 40%. If we review a week later, they're up to remembering over 50%. And if we review a month later, they're even higher than the 75% that we started with. So this is about when we review. It's cool, because I think we review too much, and we keep the ideas in their working memory, and we don't give them time to process it and put it into their long-term memory. So they never have to practice retrieval. And I think that's how we see students struggle on major testing situations. They can't retrieve the fact or the skill when they actually need it, when it's not from last week or yesterday. It does make sense, doesn't it, Laura? But it makes so much sense, and yet I had never thought of it before. So it's kind of one of those, oops. Because here's my practice. I either study, tested, or maybe over the whole unit we just studied something new, studied another thing new, studied a third related topic, and then tested at the end. Or maybe I thought I'd get smarter and I'd do a little bit and then I'd give them a mini quiz, okay, or a pop quiz or a weekly quiz, because I didn't want them to go to the whole unit test before I tested them again. I wanted to just kind of keep it all fresh and going on. Here's what they say. The best way to get students to learn something that you've already taught is not to review. It's to test them on it. And when I say test, I don't necessarily mean a formal test, but challenge them on it, or it's a low-stakes test. Test, test, test. It's not reteach, reteach, reteach. It's not review, review, review. Think of how many times you've maybe reviewed a skill. That apparently does not help them to learn it. It's giving them a test on it. The quote from the book that resonated with me, testing compared to rereading can facilitate better transfer of knowledge to new contexts and to problems, and improves one's ability to retain and retrieve information that is not tested. So even when we keep going back and testing them over and over and over again, it helps them with their learning of ideas that we're not even testing at the time. It just keeps that brain and the highways of information that go around the brain moving better, whether that's the topic that we're testing or not. Absolutely. I see all these comments. For me, it's how to log into my report card, right? I do it every year, but I only do it twice a year. I've never put that in my long-term memory. That's always in working memory, which now that I'm 50 is very, very limited. So that's a problem. The book talks about the need for that feedback and the guidance. So that is where we need to put our emphasis, is on that corrective feedback. And we need to coach students to own their own learning. Having students take responsibility for their learning is all through Growing Success and all through our curriculum documents, but I don't know that our practice actually allows them to, because we tell them what to do and when it's due and how to do it, and we keep reminding them certain things and reteaching that, you know, they can passively sit and participate and possibly even achieve high achievement and not own their own learning, really own their learning. The other thing about this targeted feedback, the targeted part, make sure the feedback is targeted at your learning goal, and make sure that you don't throw the whole kitchen sink at the students. So you can't say, well, you did this wrong and this wrong and this wrong and this wrong. Your feedback is for the one next thing they could do to make their work better. And that's the kind of targeting that Black and Willem talk about to be successful. Reflection. Reflection they talk about, we need to ask our students to reflect on what they learned, on how they learned it, on how they felt about learning it, because reflection is actually a form of retrieval. So the book suggests that we always consider including more reflective pieces in for our students, because it helps them practice retrieving their feelings, their understandings, their misunderstandings, their actions, and that's going to be positive on their learning. So I've done a whole lot of talking in that first almost hour. I'm going to stop talking for a minute and I'd like you to take a second to watch this video. This is Doug Rohrer. As you can see, he's a professor of psychology at South Florida. This is about a 5-minute clip that just kind of summarizes these ideas that I've tried to share with you and puts them in different contexts. So if you could please watch the video, and when you're done, give me a green check mark. And with 49 of you in the room, when I see about 45 green check marks, because some might be away, I'll probably go on to the next. So 5 minutes, maybe 6 minutes, and I'll start talking again. I hope you find this video helpful. Yep, sorry, Caroline. If you could just click on the link, Michelle put it in the chat, and that way everybody can watch the link on their own browser. Yep, or cut and paste. The link should work with a click, though, and take you to another browser page. Okay. Oh, now I hear myself twice. Michelle?
Yes, yes. Do you have an echo?
Yes. Well, I think I'm in the room twice.
Oh.
Can you boot my second one?
I only see you once. Where are you? Hold on a second. Oh, yes, here. Okay. Let me see how to. Okay, I'm going to remove you here. Okay, I've removed you at the bottom. Can you still hear me?
Yes, I can.
Okay,
can you
so
hear
that's
me?
it. Yes, we can hear you. That's fine.
Thank you. Sorry about that, everybody.
Yeah, there seem to be problems for many participants tonight, and I really don't know what's happening. It could be on Blackboard's side, because I initially thought it was a problem with my internet, but since you were booted out, and I see that a lot of participants were booted out and had to come back, it looks like maybe the problem is on there, and I don't know. I really don't know. But sorry.
Yeah, so thanks everybody for coming back and sticking through the glitches. Anybody have a comment to make about the video? I'm going to grab the mic or just type something. He presented the ideas much more succinctly than I did, but I thought maybe if you listened to my ramblings about my new understandings from this book, it would make sense. And that just kind of recapped what I believe. So all of this that we have talked about would apply to any subject. But I wanted to talk then, because it's what I said I would talk about, with how I'm doing this in my math class. So this has just been cut and pasted from my long-range plans. Don't get too hung up on any wording. This was just me one night putting down my thoughts quickly without very specific thought to vocabulary choice. But this whole notion that I was going to cluster the overall expectations and work through them. I was going to make sure I still taught through problem solving. The next one, where I put the emphasis on math, reasoning, and communication, I think that's a hangover from my traditional approach, when I found it hard to actually coach through all the processes, because now that I'm spiraling, this line makes no sense to me, because I coach on all of them and I don't value one process over the other. In fact, the one that I struggled with the most before that, choosing accurate or computational strategies, is maybe the one I do the most, because it's required by the students the most. When I do cluster, as I go through each time, I'm going to try to make sure I cluster the expectations differently, because how we present things can create false understandings for students. If I do bring out the spinners or talk about probability, the kids in my class will say, oh yeah, we're doing spinner math, because they've made connections that don't necessarily ring true, or my students need to know that probability involves much more than just the spinners. And my goal was to address each overall expectation at least twice per term, weighting more heavily on the third time through. As it turns out, I have actually addressed all the overall expectations. I'm writing my report cards Friday on the PA day, and when I look through, I can report on all 14 of the overall expectations in all 5 of the strands. And so my second term, not all evenly, granted, but I have hit, and we have covered, and I have evidence of what students can do on all of the expectations this year, because I was looking for clustering. And so that is the key that helped me with this spiraling. Here's an example of my cluster. This was maybe the first one I started. The big idea was the proportionality. And when we were doing proportionality, there's a lot of cross multiplication. It comes in when you need to reconcile a ratio, especially if it's expressed as a fraction. 2 to 5 is what over 10, and so when students cross multiply, they can easily find the missing term in the ratio. Or when they're given not a start unknown algebra problem, but maybe a change unknown algebra problem. So if the area is 48 centimeters squared of a rectangle and the length is 12, what must be the width? And that revolves some cross multiplication or some moving of the algebraic ideas. The other thing is definitely my first one here because it says I'm really going to focus on the equality, the idea of equality, and the meaning of an equal sign, because it drives me bonkers when students use an equal sign to mean and then I did this, and then I did this. So I really wanted to make sure my students understood that an equal sign means equal. It's balanced. You can't put two quantities on either side of an equal sign that aren't actually equal. So I went through and I started picking up some ideas of skills that students would need to do when they're doing another expectation. So for example, determine relationships among units and measurable attributes, including area of a circle. Well, to find the area of a circle, we use the proportion, which involves pi. So then there's some algebraic reasoning in there, and there's also the number sense of the proportionality. So I've addressed 3 strands, 4 overall expectations, just by doing this one little cluster on circles. So at this point, what I was going to do is give you time to go into your curriculum and see if you could find some clusters. Green check if you find that that would be a valuable use of 5 minutes. Red check if you just want me to keep going. So green check if you'd like 5 minutes. We'll go majority rules on this. Red if you just want to go and I'll keep talking. Could you collaborate? Absolutely. Oh, you're talking about in the chat. Sorry. Hey, is there a conference and can I come? Okay, there are a lot more red X's. So we can set up, if people want to collaborate, you can email me or tweet it out and we can absolutely build up a couple Google Docs and kind of share and look for these clusters. That would be awesome. But I'm not sure if that is going to work. So you know my Gmail account if you email me or tweet me, and I'll definitely set that up. Maybe after report cards we can spend some time collaboratively online and get some of these clusters planned. So I bit in, I jumped in. Here's the thing I'm thinking now. I don't think you have to pay attention to all these clusters quite as much as I'm going to this year to enjoy a benefit in student learning. I think if you really just wanted to get started and you have 3 traditional units, and you did the first part of Unit 1, and then the first part of Traditional Unit 2, and the first part of Traditional Unit 3, and then went back and did the second part of Traditional Unit 1, but at the end of that you tested from all 3, and then you kept moving through your units that way, I think you would recognize some of the benefits of spaced practice and interleaving and varied practice without having to rejig everything about your math program. So I think that is maybe a great first start into spiraling, one I wished I'd maybe thought of before. So here's a problem that I gave my students to, not the first bit, well, you can see there, it's probably my 3rd cluster, so because it's the end of September. Interestingly enough, this question has been on both the grade 6 EQAO and the grade 9 EQAO. So that's a little interesting fact, but I put it up there. And the thing that I love is because we had done some work on circles and algebra and making sure that we knew what the variables are, so we defined like diameter, this is what one group of students submitted. I didn't teach them this specifically, but they went and they defined their variables and they wrote the algebraic expression, and then through some balanced model of equation solving, they got the right answer. These tended to be more successful students. Traditionally, they tend to do well on this kind of activity. So then I also have 2 boys that last year got I's in every subject because they put nothing on the paper and they told me repeatedly that they hate math. And this is what they handed in to me that day. They solved the problem. They didn't know they could solve the problem. They practiced algebraic reasoning. They practiced their division skills. They just did it in a very inefficient manner. They divided, they figured out that, well, $20 was the flat rate and a text was 25 cents, and they had $8.50 to make up the difference between the flat rate and the bill, and they added a quarter at a time and counted until they got to the $28.50. I was thrilled. Somehow, the way that the math is happening this year, it has encouraged these boys to take a risk. And I don't think that that's great feedback that I wrote on their sheet, but it was effective enough to get them to have conversations with me. And we looked at other students' work, and I pointed out to them that all their tally marks are just the division that other students recorded as $8.50 divided by 25 cents. The tally marks are evidence of that. And then we went on, and when students were visualizing, so they got to make up their own algebraic expression, not equation, and then they had to represent it visually. This task I've done before and lost a lot of hair, and this year it just clicked for them because they had worked with these concepts already in different concrete situations, that to visualize it this way did not pose a problem for them at all. Another thing I'm doing a lot now in class is the Freyer model. So whenever we come across a new concept or a new skill, we bring out a Freyer model, and now I don't even need to suggest it. Students will do it, and they will naturally record their new understandings in a Freyer model. It helps them with their reflection, and it builds their skills at discrimination. The whole bottom, what it is and what it isn't, the examples and non-examples, help students distinguish and discriminate when is an appropriate time to bring out that vocabulary word or that algorithm or that algebraic expression. So I find that teaching this way, using the Freyer model as a organizing for thoughts, has been really powerful. The other thing, again, to build their discrimination, is we do a lot of Venn diagrams. What's the same and what's different about these two algebraic equations? And just by having students think about this and practicing thinking about this, it helps them when a problem about a triangle comes at them from out of the blue, they're successful. All last week, I gave students questions, about 3 or 4 problems a day that they worked on independently. Students didn't balk at all. They were successful, and I got no blanks on any questions because they felt like they had something to write. They were able to discriminate and to figure out what was related to this problem. And I think it's because lots of use of the Freyer model, lots of use of these Venn diagrams to summarize our understandings. And then it's easy for me to identify misunderstandings as well. I do a lot of surveys too, where I ask students, because we talked about these desirable difficulties, but they also talk about the students have to practice effortful learning, that they have to put in some effort. And we watched a lot of Jo Boaler, and when she summarizes Carol Dweck's research on growth and fixed mindset, and how it's about effort, and it's about what you believe your effort could be, and you believe your ability, that will improve your product or your achievement. It's not enough just to say, oh yeah, I can do this, go get it. You actually have to match that with some effort. And then we actually brainstormed, because this shocked me, and I was transparent with the students, and I was telling them about how effort does pay off. And the students, though, are products of mass practice. It feels really good when you practice, 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 and take a test and do well. Early on in the year, as I'm starting this interleaved practice and my spiraling approach, it didn't feel productive to students. They tried, they knew they made a lot of mistakes, and all of a sudden we were going on to another topic. And then the same thing happened. They tried, they made mistakes, some of them, lots of them still, and then we went on to the next. And so they were very uncomfortable with that, and I don't know that they knew what trying hard looked like anymore in math class. So we did a lot of deconstructing. What would it look like if you were putting in more effort in math? What would it look like when you're solving a problem? What does it look like at home? And that's really changed how they see themselves as learners and how they participate in class. Talk a lot about performance goals versus learning goals. My students have performance goals because they've been in school long enough that that's what was rewarded. Doing well, getting the right answer tended to be what was rewarded on the report card. And we've really talked a lot about what a learning goal is. If your goal is just to get the 10 multiplication questions right, then you can cram. You can learn the trick. Maybe you know that it's not for you to wonder why, just invert and multiply. That's how I still divide fractions, because my understanding is still just developing on why, how to divide fractions, really understanding the concepts, because I had that little rhyme in my head, because that helped me meet my performance goal of getting all those dividing fractions questions right. It was not my learning goal. See Lisa's question about how do my good at schools kids manage this? They did not like it at first, and I actually let a couple of the kids read my Make It Stick, and I showed them that Doug Rohrer video clip, and I showed them that one from Bjork, and because they trust in academia, they believe it would work, and so they trusted me, and now they're seeing success because, like, we did a kind of an exam situation, and they didn't need to study a lot, and they felt very comfortable, and now they're starting to see the success and the payoff of this approach. So they fought in the beginning, but now they believe it. Yeah, I did have 2 students who read the full book, and another student who just kind of read the chapters that they, that I was talking about, and so making it transparent is something that I'm really trying to do with the students to help them understand how they learn. I want my son in university to read this book very soon. We've kind of all talked about this, and green check if you're familiar with the distinction between fixed mindset and growth mindset. Yeah, lots of green there. So we talk about that with the students, and I talk about it over and over and over again. I've shown them TED Talks and all kinds of things. So I am giving up math classes, and we're not doing math. Yes, there were air quotes there too. I am talking about learning in class, and it's improving their math tremendously to redirect some of this time that I have with them. So the positives that I recognize, I do see the clock, so I'm going to maybe go quickly. The transfer of skills to various concepts and contexts. I had a student where I wrote what I thought was a Pythagorean question, where they had to do a squared or c squared equals a squared plus b squared, but instead the student just drew a 2-scale map and did the measuring to tell me the length of the hypotenuse, as opposed to using the formula. And I talked to her about it, and she said, well, I understood the scale and the proportion, so I just made sure my diagram was to scale so I could take a measurement. And then we talked about situations that her approach wouldn't work. What if there were decimals? What if the numbers were kind of ugly, And then she said, well, then I could learn how to do it with the calculator and solve it algebraically. I said, awesome. That's fabulous, the fact that you're able to just solve the question. They're becoming more willing to take risks and to just reason through a problem as opposed to try and remember the right way to solve it or the algorithm that was used to solve a similar problem. They're just starting to really wrestle with the idea, and I'm getting some wild solutions. I gave one problem, and I think we counted 7 different strategies that successfully solved the problem. That's awesome, and students are kind of really excited to see that their thinking pays off like that. I have such a bank of evidence about how their student skills and their problem-solving skills and all of these process skills play out in this approach, because they do have to select tools and computational strategies authentically. It's not a fake thing. They do need to authentically reflect in this situation. And I can give them all kinds of coaching and all kinds of feedback to help them develop these process skills. Conversations are happening in my class. They're less about how to do the math and more about what to think about. And I hear students, instead of saying, well, did you try to do this? Or I hear them saying, would you consider, or have you thought about? And as opposed to just, here, watch me do it. So that's really exciting for me, to think that now we're not a class of one teacher and 25 students. We're 26 students and 26 teachers, and we just keep shifting the role all the time. How often do I change my cluster? When it's done. It's really like one problem, one problem, one problem. So, you know, maybe 2 days on one topic, maybe 3 days, then I go on to the next. It's pretty quick. That's why I got the whole year done, again, air quotes, in one term. Time. When I was teaching through problem solving in a unit and I knew the next day was going to be the next lesson, I had to really process their work from the day before and assess their individual practice so that I could give targeted instruction for the next day, so I could make sure my pairing of students working together was intentional. But now, if I'm not going to revisit that topic for another week and a half, 2 weeks, I have time to really make sure the intentionality of my instruction and my pairing and my targeted instruction, it's much more deliberate and it feels better, especially since we don't just teach math, right? So we don't just have all day to plan the best math lesson. We've got other things going on in our day. So the fact that I can wait and really target who's going to work together the next time, that helps. Helps me with my differentiation too, because again, I have the time. Questions I still have? I have a question about when I consolidate a problem-solving lesson, how much do I consolidate? Because if we are going on and we're going to hit this again, I don't want to steal all their learning. I want to make sure that there's still productive struggle and deliberate difficulties for them the next time. I'm wondering about, is a whole class consolidation, does that make sense anymore? Or should I be doing small group consolidations? Or even better, individual consolidation discussions? And I have to figure out if I have this amount of time. I don't have a lot of students in my class with learning difficulties. I definitely don't have anybody in here with dyscalculia or something like that. So how will this approach affect those students? What about a student on the spectrum? This way of changing all the time, I'm not sure that that would work. So I have to consider that when I do have a student like that in my math class, and make sure that my approach is respectful to their needs. And I'm not sure that this will be, and I haven't figured out how I'm going to change that. And how much does my choices of clustering affect their learning? I don't know. If I made different cluster choices, would their learning be stronger? Would it be weaker? How do I lessen that initial frustration? I was honest and I told you that the kids did not like the beginning of the year because it didn't feel like they were being productive or successful. Is there something I could do next time to lessen that? Or maybe is that frustration, is that necessary? And is that why we went through that together? And is that why I feel like we're really making progress quickly now? And is there a good way to track which expectations I've addressed and plan? I have no idea. Right now I've got about 8 copies of the curriculum with highlighter colors, and I write on them, and I just try and make sure that I have addressed everything, because that's important. Yeah, Lisa, that's true. I don't have anybody with major learning difficulties. Different cognitive abilities, but I do not have anybody who, in this class, who really has an IEP that requires anything beyond, simple accommodations. And because I teach in such an open way, where differentiation's key and kids can show me anything, my accommodations don't even really happen, because everybody gets accommodations, because you just have to show what you know. I know. I'm very lucky. I will say that. And that's why I did want you to know I am having good success, but that is the reality of my classroom. The last slide from me, and then I know Michelle's going to jump in and ask you to complete a survey, but I wanted you to have this video. She is a principal in Ontario, I assume somewhere in the Waterloo region, and this TED Talk is 20 minutes, so beyond what we would do tonight. But I wanted you to get it, and it will be in the resources that you get shared tomorrow that helps you just kind of, I don't know, it kind of recaps everything I've said probably in a little funnier way and maybe more concisely. So, there are 4 minutes left, and I know Michelle's going to want you to do a survey for sure. And I also want to say that I've been asked to do 2 more math workshops or webinars. So if you would like something addressed, if you could type what you want to see in another webinar in the chat box or in the survey, I can maybe make sure that what you want to talk about or listen to is addressed. Thank you, everybody, and I apologize that there wasn't a lot of time for you to talk. Thanks for staying and listening, especially since I know that you have reports to write and IEPs to revise and all that kind of stuff. Busy night, but please do complete the survey because it does help OTF make sure that the PD they offer is the PD that you want. Thanks very much. I'm going to stay around in the room if you want to talk after, but Michelle, I'll turn it over to you.
Thank you, Mary-Kay. Really wonderful presentation, and you are taking words out of my mouth here, so you're doing some of my work. That's great.
No.
Thanks. I'm really happy that you are such a master at using Blackboard, and you always keep cool under pressure, even when you get booted out. As I said, I think that most of us experienced some problems with the session tonight. And I guess these are the mysteries of the internet and these kinds of webinars. You never know for sure. Sometimes it works flawlessly, sometimes it doesn't. I would say, I'm saying that just to the participants, to let you know that 90% of our sessions work well. And sometimes we have some strange issues happening, and tonight it might have been because we had a large group. I can't be certain of that. I don't know really. But it was okay. I mean, we made it through. As Mary-Kay said, maybe I jinxed it early on when I was rejoicing. I should wait for the end of the session before doing that. Anyway, despite all the small difficulties, I must say, Mary-Kay, I'm really incredibly impressed how you managed to foster participation and keep on top of all the comments and questions in the chat box, even when they are coming fast and furiously. So anyway, thanks so much for this excellent and particularly enriching presentation. Once again, it was really wonderful. As a side note, I must say I love the humor of your student who wrote that Joe sent 34 text messages to his ex-girlfriend. I thought that was quite funny, and I think that you should give him extra points for that response. I think it's well deserved. And as always, also want to thank all of you for being such fantastic participants and such motivated teachers, and for sharing your ideas and your suggestions in the chat box, and for answering all the questions along the session. I noticed Lisa, Kamaljit, Bill, Laura, Julie, Kim, many of you. I can't name you all, but thanks to all for this, for your participation. It was really a fantastic session. So I have a couple more slides, 4 to be exact. So if you allow me to take a few more minutes of your time. We have a number of particularly interesting sessions in the coming days. Tomorrow I'm actually moderating a session in French titled Using Assessment to Increase Student Proficiency in FSL with Jen Rochon. Alors, s'il y a des francophones parmi vous, je vous invite à nous rejoindre demain soir. Je crois que ce sera le fun, comme ils disent dans la belle province. Une de nos rares sessions en français, donc demain soir. Tomorrow as well, one of my colleagues will be moderating a session with Kit Luce on exploring spatial reasoning. Then on January 29 and 30th, we have 2 new facilitators and 2 new sessions that I would warmly recommend. We still have lots of spaces for these 2 presentations, so please don't hesitate to register or to pass the invitation to your colleagues. And on January 31st, 31, I never know how you say it, I guess January 31st, the session by Edward Schroeter has been cancelled for personal reasons, and I have heard that it has been rescheduled for April 18. So what I would recommend is that you visit the OTF website. I'm going to paste the links here for our calendar and our webinar resources, and you'll be able to find all the information about upcoming sessions on those pages. I also would like to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. And here's the link for you to apply for that subsidy. I'm going to paste it in the chat box. Here it is. And as Marie-Kay mentioned, we need your feedback. It's very important to us to obtain subsidies for future webinars. And when you quit Blackboard, you should be redirected to a survey page. And after the survey page, you will also be redirected to a feedback, first a feedback questionnaire and then a certificate of participation that you can add to your learning resume. And in case you are not redirected, I'm going to provide you with the links as well for the survey, for the feedback survey, and for the certificate of participation. I would recommend that you cut and paste these 2 in case you are not redirected. And I'm also going to provide you with the resource page for tonight's session. It will be live tomorrow morning. I'm going to work on that tonight, and it should be live later tonight or tomorrow morning. So that's it. As we conclude this presentation, I would like to invite you to follow OTF on social media as well as on our OTF website. I'm now going to end the recording of the session. Thank you once again for your participation in tonight's session. We certainly hope to see you again very soon on OTF Connects. Bonne fin de soirée à tous et à toutes, et merci encore.